Hello and welcome to Introduction to Remote Sensing. I'm really glad that you enrolled in this course and are interested in learning more about remote sensing. My name is Matt and I will be your instructor for this course. I really look forward to teaching you all of the fundamental principles of remote sensing. The purpose of this course is to help you not only understand what remote sensing is and how it works, but also to give you the knowledge to apply this technology in any of your future projects. I aim to teach this course so that you will be able to use remote sensing for a variety of applications, not just agriculture or geology, but anything that comes across your path. I really hope that you enjoy this course and feel free to ask me any questions that you might have at any time. So let's get started. These are the main principles that I want you to take away from this course, and by the end you should feel comfortable knowing the basic fundamental principles of remote sensing and being able to apply them to real-world scenarios. The next lecture we're actually going to look at a bunch of different remote sensing applications ranging from environmental, agricultural, and geological. After that we're going to dive straight into the physics of electromagnetic radiation in detail, and specifically how light interacts with atmospheric particles and how we can correct for them when we look at our images. We'll also look at how light interacts with different land cover types, such as vegetation, water, soil, rocks, and minerals. Different land cover types reflect and absorb light differently, so this is the main concept on how we can distinguish between them in our remote sensing images. We'll also look at the different satellites being used today and some of the most common, such as Landsat 8 and Sentinel-2. And at the end you may be wondering, well, what if I want to investigate something that's not vegetation or this certain type of mineral or rock? Well, I'll give you the steps you need for creating your custom algorithm to investigate any material that you come by. These are the major topics that we will cover during this course. Like I said before, we will go over environmental, agricultural, and geological applications, and I will provide many examples of each. We will go over the electromagnetic spectrum and how different wavelengths of light interacts with atmospheric particles and different surface types. We will also learn how to pre-process images to ensure accurate measurements and data analysis, and this includes radiometric corrections and atmospheric corrections. We will look at the two different sensor types, passive and active, and the four main resolutions associated with them. We will also look at spectral signatures of different materials. So each material that we are investigating reflects and absorbs light differently, and this is how we can classify them in our remote sensing images. And lastly, we will look at different software packages that we can use to process our images. Over the next few slides, we're going to look at what exactly remote sensing is and the definition of it. So there's going to be a lot of text, but I wanted to give you the precise definition on what exactly it is. So the first definition is remote sensing is the science of obtaining information about an object, area, or phenomenon through the analysis of data acquired by a device that is not in contact with that object. So what this is saying is we have a sensor that's far from the object, and we're getting data that we can relate and further investigate that surface. The second definition goes in a little bit more detail, saying that remote sensing is the practice of deriving information about the Earth's land and water surfaces acquired from an overhead perspective, using electromagnetic radiation in one or more regions of the spectrum reflected or emitted from the Earth's surface. So this goes a little bit further in saying that the sensor is picking up light reflected from the surface being investigated. And as I said earlier, different materials reflect and absorb different wavelengths of light. Here's another remote sensing definition that goes in a little bit more detail. Remote sensing is a tool or technique similar to mathematics. We use sensors to measure the amount of electromagnetic radiation or light exiting and reflecting from an object from a distance, and then we extract that valuable information from the data using mathematically and statistically based algorithms. The remote sensing data that we get from the sensor can be used in other spatial data techniques or tools such as geographic information systems. So you may have heard GIS before. What I like to think of, remote sensing is a science and GIS is a tool that we can use to analyze that remote sensing data. Alright, so this is the last remote sensing definition that I want to provide you with, but it's more on the information we can obtain about an object. Remote sensing sensors can actually be used to obtain very specific information about an object. For example, we can look at the top of a diameter of a tree. Just think how long it would take you to go out and measure just even 10 of those trees. Whereas we can use a remote sensing image and look at 100 of them very quickly. Another example is looking at the boundary between species of trees. Instead of going out and by hand mapping each individual tree and where it is, we can use remote sensing to easily see the boundary of, say, 100 square miles of a forest and see where these specific trees are. And we do this by looking at electromagnetic radiation reflected by that certain species of tree. So say we're looking at cottonwoods, a cottonwood versus a pine tree reflects and absorbs different wavelengths of light. They may be close, but the exact wavelengths are different. In the next section, we are going to look at many different examples of environmental, geological, and agricultural remote sensing applications.